Okay, so we've got this curve in part A here, y equals x squared minus 8x plus 14, and we've got this point then P on the curve, which is called coordinate 6, 2. So it lies on the curve, and we are asked to find the equation of the normal. Okay, so remember, for the normal, okay, we first of all would draw the tangent at this particular point, P, which is 6, 2. And remember then, the normal is perpendicular to the tangent, okay? So it goes at right angles to the tangent. So first of all, we've got the coordinate that it goes through. We need to work out the gradient, okay, of the tangent. So we do that by working out dy dx, okay, which will be 2x minus 8, okay. We've got that there when you differentiate it, and then at the point P, so at P, dy dx will equal to 2 bracket 6 minus 8. So I'm subbing in the x value, okay, I'm subbing in the x value 6 into dy dx, and I get my answer out to be 4. So that is the gradient of the tangent. So remember then, you use m1, m2 equals minus 1, because we want the gradient of the normal. So you put 4 there, times m2 is minus 1, so m2 is minus a quarter. So this will be then the gradient of the normal. So then if we use the equation formula, y minus y1 is mx minus x1. For the point at P, which was 6, 2, remember, so y1 is 2, the gradient is minus a quarter of the normal, and then x1 is 6. So take the 4 over, 4 bracket y minus 2 minus 1 x minus 6. Expand 4y minus 8 is minus, then times through there, minus 1 times x is minus x, minus 1 times minus 6 is plus 6. So we get 4y plus x is equal to 14. So that's the equation there of the normal. Okay, so we've answered part A. Now in part B, they ask for, what have we got here? They ask for the point Q, it says lies on C, and is such that the tangent to C at Q has the equation y equals 2x plus c. So sometimes it's good to sort of have a quick sketch and appreciate that this point Q, right, well, we don't know what the coordinate is, okay, we just know it's point Q, but they're saying that the tangent has got this equation, y equals 2x plus c, yeah, and it's saying then find the coordinates of Q and the value of c. Well, what we could do is recognize that this is very similar, okay, or it's exactly of the form y equals mx plus c, okay, and of course from that then we can determine what the gradient is of that line. So when you compare the two, we can see what m is. We can see that m here is equal to 2. In other words, the gradient of the tangent is equal to 2. Now, because we know the gradient of the tangent, we can then sort of work in reverse. We can work in reverse process to get the x value. So if you remember, before we had y was equal to x squared minus 8x plus 14. We worked out then dy dx to be 2x minus 8, okay? But the point with this now is we know that the gradient of the tangent is 2, okay? Which also must mean then the gradient of the curve, so dy dx is 2. So in other words, we'll set dy dx to equal to 2. So therefore, my gradient function, 2x minus 8, is equal to 2. We'll solve it, and we can work out what x is. So 2x minus 8 is 2. So 2x is equal to 10. So x will equal to 5. Okay, so we've got my x coordinate 5. We can easily work out what the y coordinate is by subbing it in. So we can get y equals, we could get y equals 5 squared minus 8 times 5 plus 14. So we can work out what that is. Okay, so we've got 25, take away 40 is minus 15, add 14 is minus 1. Okay, Okay, so q is equal to 5 comma minus 1, and then to work out c, we'll just sub this into y equals 2x plus c. So we'll sub it into the line equation to work out what my c is. So your y is minus 1, your x is 5, sub it in because it'll satisfy this line because the line goes through that point, and you get minus 1 equals to 10 plus c. So then when you work that out, then that means c has got to be minus 1 minus 10 equals c, which means c has got to be minus 11.